This is the review for the test on logarithms. For number 1, we're asked to simplify. So the first thing you want to do is take the exponent and condense it. So I'm going to move the 3 to the exponent of the 5 so that I have 10 raised to the log 5 cubed. Now I know that I have a rule that says a to the log base a of x is equal to x. Well, here we have 10 to the log base 10, so a log base a of x, which is 5 cubed, will equal 5 cubed. So the final answer here is 125. Okay, same thing for number 2. It's the same rule. We have e to the ln base e of 5 cubed. So this will also be 125. Okay, on number 3, you're using the rule a to the m plus n is equal to a to the m times a to the n. Okay, a to the m plus n is equal to a to the m times a to the n. So here, 10 is a, m is 1, and n is 2 log x. So I have 10 to the 1 times 10 to the 2 log x, which I'm going to write as log x squared. Okay, this is the rule a to the log base a of x is equal to x once again. So here we have a to the log base a of x equals x. So that's 10x squared for your final answer there. Okay, it's whatever follows the log that's going to be your simplified version. Okay, same thing here. We have e to the 1 times e to the ln x squared. So we'll bring down the e to the ln x squared. Same rule, a to the log base a of x. So we have x squared. Okay, on number 5, we're going to solve for x. Remember that if you have a log on one side, you need to rewrite the equation in exponential form. So 2 to the 0 is equal to 2x minus 5 divided by x plus 3. Now, 2 to the 0 is just 1, and I want to get rid of this fraction, so I'm going to multiply by x plus 3. Okay, so x plus 3 times 1 is x plus 3. Now I just need to solve for x. So I'm going to add 5, so I have x plus 8, and subtract x, so I have x by itself. X is equal to 8. Okay, on number 6, I want to condense first, and then I'll still have a log on one side, so I'll rewrite in exponential form. So I've got log base 3 of x squared minus x. Minus tells us to divide, so I'll have x squared plus x on the bottom is equal to 1. Now rewrite in exponential form. 3 to the 1 is equal to x squared minus x divided by x squared plus x. Okay. Multiply by the denominator to get rid of it. X squared plus x. If you do it to the right, you have to do it to the left. Okay, distribute the 3, so we have 3x squared plus 3x equals x squared minus x. Okay, now let's group everything to one side. So let's subtract x squared, so we'd have 2x squared. Add x, so we have 4x equals 0. Now take out the GCF. So 2x times x plus 2 is equal to 0. And then set each factor equal to 0. So 2x equals 0, and x plus 2 equals 0. Okay. Now check your solutions. What can I plug in and fit the domain? So if I plug in 0, I have log of 0. You can't take the log of 0. It's not in the domain. If I plug in negative 2, I'd have negative 2 squared. That's 4 minus 2, minus negative 2. So that's going to be a positive. If I plug in negative 2 here, I have 4 plus negative 2, which is also 2. So those are both good solutions. So the negative 2 is a good solution for both pieces of the log, rather. Okay, so negative 2 is our only answer. Okay, let's look at number 7. Okay, on number 7, we need to rewrite both sides with the same base. So I have 2 to the 6 minus x is equal to 2 squared to the 2 plus x. So whenever you have an exponential equation, you want to check both sides and see if you can rewrite it with the same base. If you can, that's going to make things the easiest. If you cannot, then you're going to want to take the log of both sides. So here we can drop the base because it's the same on both sides, but you want to multiply on the right. So that'd be 4 plus 2x. And now we're ready to solve. So let's just add x so that we have 3x here, subtract 4 so that we have 2, and x is equal to 2/3. Okay, on number 8, we want to condense first. So plus means to multiply. And then we'll want to rewrite in in an exponential form, excuse me, because we have a log on one side only. Okay, so exponential form, we start with the base, 1 is the power, and go ahead and distribute that x. Now subtract the 5 so that we have a trinomial, and then factor. So we have 0 is equal to x minus 5, x plus 1, and x is equal to 5 and negative 1. Now plug both solutions back into the original. 5 will be fine, log of 5 and log of 5 minus 4, that's good. If I take the log of negative 1, that's not in the domain, so we'll eliminate that solution. So just x is equal to 5. Okay, on number 9, we have the same base here, so we can condense, but then I have a base 9 here, so I'm going to have to do a little extra work. Okay, so I've got log base 3 of x times x minus 6 minus 2 log base 9 of x. Okay, so since I have different bases, I'm going to need to use change of base formula to rearrange this one. Okay, so I've got log x squared minus 6x divided by log 3. Again, that's change of base. You'll put the log of this number on the top and log of the base on the bottom. So 2 log x over log 9 for that second term. Okay, now I'm going to rewrite 9 as 3 squared, and I'm going to move the 2 to the front. And that way we can cancel out these 2's, and I can get rid of the denominator, since it's the same under both, by simply multiplying by log 3. Okay, so now I have log x squared minus 6x minus log x equals log 3. Okay, because it canceled out here. All right, now I want to condense. Now I've got base 10 everywhere, so I can do that pretty easily. Minus tells me to divide. I've got the same log on both sides, so I can get rid of it and solve for x. So x squared minus 6x is equal to, multiply by x on both sides to get rid of the denominator. So I have 3x. Okay. Now, let's go ahead and move everything to one side. So I have x squared minus 9x, because if I subtract 3x from negative 6x, I have negative 9x. Take out the GCF and solve. Okay, so x is 0 and x is 9. Now check your solutions. If I plug 0 in, that's not in the domain, so I eliminate it. If I plug 9 in, I've got log of 9, that's okay. Log of 9 minus 6 would be log of 3, that's okay. And log of 9, that's okay. So the only solution is 9. Okay, let's look at the next page. Okay, on number 10 it says to graph the function log base 3 of x minus 2 plus 3. Okay, so the first thing you want to do is think about the parent function. For the parent function, you always graph, for the x's you always use 1 and the base, and the y is going to be 0 and 1. Okay, so whatever the base is, that's what you're going to put right here. That's the only number that'll change. Otherwise, you'll use these two key points. Okay, so 1, 0 and 3, 1. Okay, and I just like to kind of dot this one so I know what it looks like. And then identify your transformation. So this minus 2 means to move it right 2. And the plus 3 is up 3. So take these 2 points, move them right 2, up 3. Again, right 2, up 3. And then plot your points. Now the asymptote was at 0. Since I moved right 2, the asymptote is going to be at 2. Okay. The domain will be 2 to infinity. Start at that asymptote and go to the right. The range will be negative infinity to infinity. Okay, for number 11, we're solving algebraically. So we've got an exponential equation. I can't rewrite both sides with the same base, so I'm going to take the log of both sides. So go ahead and bring down the exponent in parentheses. Take the log of both sides. Okay, now distribute so that you can get x out of the parentheses. Okay, now what you want to do is get all your x's to one side and all your numbers to the other. So I'm just going to subtract 3x ln 3, and I'm going to add the 2 ln 5 to move it to the right. Okay, so bring down x ln 5 minus 3x ln 3 is equal to 2 ln 3 plus 2 ln 5. So distribute, move all your x's to one side, your numbers to the other. Now factor out x. Okay, and last step we have divide. And then we'll just condense and we're done. So x is equal to, this 2 becomes an exponent, so that's ln 9. This 2 becomes an exponent, so that's ln 25. Well, 9 times 25 is 225. Here we have a 3 for an exponent, so that's 27. The minus means to divide, so 5 over 27. And that's your final answer. For number 12, it says solve using a graphing utility. So we're going to take e to the x and put that in y1. We're going to put x squared in y2. So your graph will look like this. Oops, that should go all the way to the origin. There we go. Okay, so this is y2, this is y1, and you're going to calculate where they intersect. That x coordinate is going to tell you where the values are equal. So in this case, it's going to be negative 0.703. Okay, and I'll show you what that looks like in the calculator. Okay, so again, you go to y1 and you put in e to the x. So e raised to an exponent is second ln. And then you put x squared in y2. Now to calculate where they intersect, hit second trace, which is calculate, 5 for intersect. And I see where they intersect, it's right there, so I'm going to go over and hit enter, 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 negative 0.7035. That's your answer. Okay, on number 13, we're getting into the word problems. Okay, I'm going to assume you've already read the problem. We've got our function. It says determine the number of days it will take for a minimum of 2,000 students to become infected. So 2,000 is the number of students after time. So that's going to go in the place of n of t. Okay, now you can use your calculator to do this. You can put the function into y equals and then look for where y is 2,000. Okay, so you could put both sides into y1 and y2 and calculate the intersect again. Or you can solve it algebraically. Okay, to solve it algebraically, I want to get rid of the denominator, so I'm going to multiply by it on both sides. So I'll have 2,000 times this 1 plus 49.99 e to the negative 0.8t is equal to 5,000. Okay, now I'm going to divide by the 2,000 so that I have 1 plus 49.99 e to the negative 0.8t is equal to 5 over 2. Right? If I divide by the 2,000, the 3 zeros are going to cancel out. Okay, now I need to go ahead and subtract 1. So I've got 4,999 e to the negative 0.8t is equal to 5 halves minus 1 is the same thing as 5 halves minus 2 halves, so 3 halves. Okay, divide by the 49.99. So now I have negative 0.8t for my exponent, and that's equal to 3 over 2 divided by 49.99. Okay, now I need to get the t out of the exponent, so I'm going to take the natural log of both sides and bring it down. Okay, now ln e is just 1, so I can get rid of it. Let's divide by negative 0.8, and I'm done. So t is equal to the natural log of 1.5, which is 3 over 2, over 4,999, divided by negative 0.8. Okay. And when you put that in the calculator, you should get 10.139, and that's days. Okay, when you put that in the calculator, make sure you put your fractions in parentheses so that it'll use the correct order of operations. Okay, on number 14, let's see, we have compound interest. It says how long will it take $100 to become $1,000. So 100 is your initial amount, your a sub 0, and your 1,000 is your amount after time. I want to know exactly what time is when the interest rate is 8%. So remember that you write that as 0.08. You have to move your decimal. Okay, for annually compounded, we'll have the number of compoundings per year would be 1. So we'll take this formula, P of t. You could use a P instead of an A if you want. Okay, so the amount after time will be 1,000 is equal to 100, the initial amount or the principal amount, times 1 plus 0.08 divided by 1, your rate over your number of compoundings per year, raised to the 1 times t, which is just t. Okay, so go ahead and divide by 100 on both sides so that you have 10 is equal to 1 plus 0.08 to the t. Now take the natural log of both sides, so we have the natural log of 10 is equal to t times the natural log of 1.08. And then just divide by ln 1.08. So we have t is equal to ln 10 divided by ln 1.08. And that gives us 29.92 years. Okay, compounded quarterly, that changes the n value to 4 times per year. So we'll set it up the exact same way. 1,000 equals 100 times 1 plus 0.08 divided by 4 raised to the 4t. Okay, so we'll divide by the 100 and get 10 again. Now 1 plus 0.08 divided by 4 is 1.02. Now natural log both sides. Divide by 4 ln 1.02. Okay, so t is equal to 29.069 years. Okay, so pretty close. It's very slightly different. Okay, compounded continuously, you know that means to use the last formula, P of t equals P sub 0 e to the RT. So we have 1,000 is equal to 100 e to the 0.08 for RT. Divide by 100. Take the natural log of both sides. Divide by 0.08. So t will be approximately 28.782. Okay, so this would be your best option if you were choosing which type of interest to go with. Okay, that's your review for logarithms. Good luck on the test.